Bismillah ar-Rahman Rahim. In this session, we will discuss chapter 14 on differentiation 2. Earlier, we have discussed differentiation 1 in previous exercises, and in this session, we will discuss exercise 14.1 under additional mathematics course for IGCSE and O level students. And this is a little advanced version of the previous differentiation topic. And here we have this exercise 14.1, and we have to differentiate with respect to x. So we have to differentiate all these expressions with respect to x. Similarly, this second part. So let's solve this. So differentiate. First, let y is equal to this e power 7x, and then we differentiate on both sides. So dy by dx is equal to d by dx e power 7x. So we'll differentiate this one. So we'll have this e power 7x, and then differentiate this power, which is 7x. So on differentiating, we have this 7. So this 7 and e power 7x. So this is the result. Similarly, for this e power 3x, let y is equal to this, and then we differentiate this, and then this power, and then we get this 3. Similarly, for this y is equal to e power 3x plus 1. So we differentiate this e power 3x and e. So this e is here, and e power 3x is, we differentiate, we get this 3x, and on this part we have this e power 3x. So from here we have this 3. So 3 is here. So 3 e power 3x plus 1. So we have this 3 times e power 3x. So this is the resultant. Similarly, for this one, so we have this e and ex square. So this ex square is here. So this is here. So this, from this part we have to differentiate 2x square plus 1. So from this we have this 2x, and from this 2x is here, and e power x square plus 1 is this. So this is g part. And similarly, for this h part, we have this 5x and 3e power under root x. So from this we have this 5x, here with this we have this x, from here with this, and from e power under root x. From this under root x is, for under root x we have this half e x power minus x. So this 3 upon 2 e power x upon under root x. So this is the differentiation of this 5x minus 3 e power under root x. Similarly, for this k part, where we have this y is equal to e power x plus e power minus x divided by 2. So we differentiate this, half will be here common, and then we differentiate this and this differentiate this. So for this differentiation, we have this e power x and then dx. So this becomes 1, and from this we have differentiate e power minus x, and this is minus x is here, and differentiate we gets minus here. So this is half e power x e power minus x. So this is the differentiation of this e power x plus e power minus x divided by 2 is half e power x minus e power minus x. So like this is y is equal to 5x square plus e power x square. So this is 5, and we differentiate, and then 5 is here, and then x square is there, and this ex power square, and from this we have this 2x, and from this ex square, and then differentiate this x square here, and from this we have result this 5 into 2x common can be taken common from here. So this is here, and 1 plus ex square. So this is 10x plus 1 plus ex powers x square. So now differentiate with respect to x. So we have this x part and e power x. So this is our u and this is our v. So this is u v dash v differential, and then v and then u differential. So u v dash v u dash is the first function derivative of second function derivative of first function. So this is u v dash and v u dash. So So this is u is here and v dash is this one. Similarly for the other part, we have this v is here and this u dash is this one. So from this u v dash we have this dy by dx is x e power x, and this is e power x. So this is e power x, so x 1 plus x. So this is differentiation of this x power ex is x plus 1 e power x. Similarly for this x square e power 2x, so this we have this x square, and for this differential we have this one, and for this e power 2x and x square is here. So from this we have this 2x, and from this here this x square, and this is e power 2x, and then e power 2x is this one. Similarly, this is on taking is common, we have this obtain these results. So let y is equal to this one. So this is 3x is here. This is v, and this is u dash plus u, and this is v dash. This 3x is u, and e power minus x is v. So by solving this together, this is v u dash u v dash. This can be right on first and this can be right on second, but anyway this will be, there is no problem because the sign is positive here. U v dash or v u dash. So from this we have simplified this one and simplify this one and get the result. So the resultant is simple. And similarly for this one, this is u, this is v. So u v dash v u dash. So this is simple. So we have obtained e power x. This is u, this is v. This is u upon v, u upon v. So this is this 1 over x can be taken as here in this case I have taken this 1 over x as a u, and this e power x is v. So this is another way we can solve it. So 1 over x is taken as u, this is u, and this e power x is v. So by taking this we can solve it. So this is u and this is v dash, and then v and then u dash. So from u dash we have obtained this. So by taking this we can solve this. We can also solve it by u by v, and you'll get the same result. So this case similarly, this is 1 over under root x is u, and this e power 2x is v. So u and v dash and v and u dash. So by simplification we have obtained this result. Similarly for this one, now part B, here we have this is considered as a u and this is considered as a v. So u upon v, this formula is dy by dx, v u dash, u, this is v dash, and this is v dash means differential of v, differential of u, differential of second function denominator, and denominator, differential of numerator minus numerator, differential of denominator, and this denominator square. So this is denominator, this is numerator. So u is numerator and v is denominator, and this is the formula that is used in u over v cases. So for this is v. In place of v we have write this, and in place of u this u here. So this d by dx, u is here and u is here minus u, and then in place of this v is here. So and in the denominator we have this ex minus 1 square. So by solving it we have this here, we have this e power x, e plus x, and this is e power x. So this, on solving this we have this result. So this is e power x square. So this is cancelled. So basically this is plus, this is minus, cancel. This is minus 2. So minus 2 e power x, and this is e power x minus 1 x square. So this is basically the differential of this y. So dy by dx of this is this resultant. In the next we have this is this part. So this is uv. We have solved this, and this is simply differential. This half is just a coefficient. So on solving this, uv dash and vu dash, and then this one alive separately, and collectively we have obtained these results. So this is simple. Similarly for this one, so this part and this part, so this is this has been solved separately. So this x square e power x is basically minus 5 u, and this is v. So in place of v we will write this v, and in place of this du by dx, so we have solved this dy dx, this one. So we have this obtained these results. So in place of v we have this v is basically this one, and dy by dx is this. So in place of this dv by dx we will write this ex, and in place of u we will write this. So we'll write this. So just plug in here this u value and v in respective positions. We're substituting this and this. So we have obtained this resultant dy by dx. On simplification we have obtained this result. So some of the variables will be cancelled, and finally we have obtained this result. So from this we have taken out some common, and we have finally obtained this result. So in question number 3, so the equation of tangent. So we have to find the equation of tangent. Let's discuss this in questions session. This is part 1. Part 2 have completed this. Find the equation of the tangent to this line. So this y is equal to this. This is the equation curve, and at x is equal to 0 we have to find the tangent, and tangent is defined as dy by dx. That's a gradient. So this slope. So this y dy by dx, we have to find the dy dx at x is equal to 0. Similarly for this we have to find the dy by dx at x is equal to ln 5, and we have to find dy by dx at x is equal to 1. So this, in this part we have to solve this there. So this is question number 3, part A. Y is given as this, and at x is equal to 0 we have to find the dy by dx. So we have just placed this in the numerator by the minus sign, so it's easy. So this is so in this way we have just take the differential of this term. This is constant is here, and for this one we have take the differential. So this minus will be here, and then minus 1. So minus 2. For this we have this value, and after that we will differentiate this inner term. So dy by dx e power 2x plus 3. So from here we have this minus 5 e power 2x plus 3 square in the denominator. For this we have this e power 2x, and then 2x is, from this we have this 2. So this 2 will be appear here. So 2 5 the 10 is here, minus 10 e power 2x, and then denominator we have this. And after this we have obtained this dy by dx, and we have to place it at x is equal to 0. So by placing at x is equal to 0 here and here, so we have obtained this minus 10, and this is 1 and plus 3. So minus 10 upon 16, so this is 5 upon 8. So minus 5 upon 8 is the answer. This is our tangent. Now this 5 upon 8. So the equation of line is basically so the y1 is basically this y is given. So at this y1 is obtained as 5 upon 4. So this is 5 upon 4 by placing values in this equation. So that will be the y1 that passing from this equation, this curve. So this y1 is obtained. So this y1 is obtained. So this is the line equation, and this x1 is 0. This is 0. X is equal to 0. So x1 is 0 and y1 is this one. At x is equal to 0, dy by dx value and this is slope minus 5 upon 8 is here, and by this way we have obtained this equation. So this line equation is basically the tangent line. So that tangent is a line on this curve. So this curve equation has obtained like this. So this is very, very important. So actually dy by dx obtained, and that dy by dx is placed here. So this dy by dx basically the gradient. Dy by dx is m. This small m is basically this dy by dx at x is equal to 0. So this is m, small m. This is a gradient. So we have placed this gradient here. You can see it here. So this is the tangent equation on that curve, on this curve. So equation of tangent, we have obtained the equation of tangent. This is basically the tangent, this is gradient or tangent, and we have obtained this tangent equation by placing it in this equation, line equation. Tangent is a line on this curve which is touching at only one point. So this is tangent, equation of tangent. Similarly for this, y is equal to this at ln. So we differentiate it. So first differentiate the part. So this is power half, half will appear here, and 1 minus half. So half minus 1. So then this becomes minus half. Half minus 1 is minus half, and then differentiate inner part, and we'll get this results. And by placing it here, we will get this dy by dx. And on this we have to obtain at x is equal to ln x, and by placing this we have obtained this 25 divided by 26 under root, and that is, and from this we have to place it for this y is equal to for this x, and we will get this y1. So this y1 is obtained as under root 6 under root 26 and that under 6 here, and then gradient is here, x is ln 5. So this is the equation of tangent, or it can further be manipulated to obtain like this here. In the third part is the same way, we can solve it. The fourth question, here we have this fourth question, we have y is equal to 5 e power x minus 4 x minus 3, and meet x at point A. So let's discuss this question first. Read the question. Question number 4. A curve equation y is equal to this 5 e power 2x minus 4x minus 3. The tangent to the curve at the point 0, 2 meet the x-axis at point A. Meeting x-axis. So at x-axis, the value of y will be 0 at point A. Find the coordinate of A. Right? So for this equation we have this, find the dy by dx at 0, 2. So and dy by dx obtained as this. So this value is obtained 10 power 2 e power 2x minus 4. So we have to find at x is equal to 0. So at x is equal to 0, this value is obtained as 6. For at x is equal to 0, we have to find the y1. So place this x is equal to 0. So y1 will be obtained, and y1 is obtained as this value. This is 2. Y1 is 2. So this is y1 is 2. M is 6 here, and x1 is basically 0. So x1 is 0. So placing by this, we have this obtained this equation. So by this equation, point A, x is 0. So y is 0. So y is 0. So x value is obtained as, so in placing y is 0. So 6x plus 2 is equal to 0. So x is equal to minus 2 upon 6. So which is minus 1 upon 3. So the A point is minus 1 upon 3 comma 0, because the y is 0, which is given in the problem. Similarly, the question number 5 can be solved, and So we will discuss this question 5. So let's discuss the question number 5. Curve has equation y is equal to e power x, x e power x. Find in terms of e the coordinate of the stationary point on this curve and determine its nature. Find in terms of e the equation of the normal to the curve at point this. At this point we have to find the equation of normal to the curve, and equation normal at P meets x-axis at A and the y-axis at B. Find in terms of E the area of the triangle OAB, where O is the origin. So this is the curve and coordinate of the stationary point. So let's just find the stationary point first, and then so this is y is this. So we differentiate it. On differentiation we have obtained this. At a stationary point we have this dy by dx is equal to 0. So when we take this differential takes 0, then this becomes 0. So e power x plus 1 is 0. So either e power x is 0 or x plus 1 is 0. So e power x is 0 means x tends to minus infinity. When x tends to minus infinity, then this becomes 0. Or x plus 1 is 0, so x is equal to minus 1. So there are two possibilities: x is equal to tends to minus infinity, or x is equal to minus 1. If x is equal to minus 1, then y is equal to, this is minus 1 and that's minus 1. So this minus 1 and this power. So 1 minus 1 over e. So y value is minus 1 over e. So at the coordinates of the stationary point is minus 1 and minus 1 over e. And now take the second derivatives, and for second derivative we have this x e power x and this. So this is the first derivative, x e power x, x e power x. So we differentiate it again, so we'll get this again, this differentiate to this. So this part will be appear like this. So this second derivative is obtained as this. So this is e power x plus 2 power e. So this is the second derivative of the dy y x. So dy by dx we differentiate it again and we obtain this result. From this we have this value. So at x is equal to minus 1, we can see that at x is equal to minus 1, we place it here. On placing, we have this dy by dx is e power minus 1. So this dy by dx square is greater than 0, that is 1 over e. Minus 1 e power minus 1 is 1 over e, that is a positive one. So that is greater than 0. So this is a minimum point. So if something it goes up, so the previous differential is a positive term. So this is a minimum point. So that's why if this is greater than 0, then the stationary point is a minimum point. This is the stationary point and equation of normal at that. So we have this x1 and y1 is available. So the slope is reciprocal of the slope. So this m is basically 2e. This is the slope of dy by dx. So at 1e. So y1 is this one, and similarly this y minus y1, and this is 1 over m. So this is m, so minus 1 over m because of the orthogonal or reciprocal of the tangent. So this m is the gradient of the tangent equation. So this 1 over minus m is the gradient of the normal equation. So this normal is basically minus 1 over 2e. If this is the tangent, so this is the normal gradient. So in place of this equation we have obtained this. So this is very, very easy, and on simplification we have obtained this. So this is question number 5, a difficult one. Equation of normal. So y minus this e minus 1 over 2e x minus 1. is the equation of normal. The normal equation of point meets x at x-axis. This meet at x-axis at point A. At A it meets x-axis. So at that point, if it meets x-axis where the value of y will be 0, so this will be 0 at that location. At point A, this value will be 0 because it's meeting the x-axis. So this is 0. So as a result, the x can be obtained as this. So the point A is 1 plus 2e square 0. Normal equation of the point P meets y-axis at B. It meets the y-axis at B. So at B position, the x value will be 0. So in that equation, x will be placed 0 for the B point. So for this point, we have placed this 0. So y minus e, in this we have obtained y. So this is B point. So A point is this and B point is this, and origin O is 0 0, and from this we can solve the area. So this is point A, this is point 0, sorry, this is O, this is A, and this is B, and this is O again. And for area we multiply this and this first, and then this and this second. So from this we have obtained this area. So we have already obtained this area. We actually multiply this way. So this is 0, this is 0, this is 0. So this will be 0. On this is 0. This will multiply to each other. So this part is here. So only this multiplication possible with a negative sign. So in area we take some magnitude. So negative sign will be omitted, and so we will obtain these results. So this is very, very important question. And in the next session we will discuss exercise